Hello, today is October 17th, and we started off with a bell ringer today. The bell ringer today was 3x plus 5 equals 14. We're asked to solve for x. Now, to do that, I'd start off by drawing some railroad tracks, as I call them. You may do one line for a river or whatever from there. Then we do work with the opposite operations in the opposite order of operations. Right now, the 3 is multiplying the x, and the 5 is being added. The order of operations would have us multiply and then add. Instead, we're going to do the opposite. We're going to do the adding first, and we're going to do the opposite of adding, which is subtract 5 from both sides. Subtracting 5 from both sides gets rid of the 5 from this side and makes this side a 9. Equal sign is still there. When I say it gets rid of it, it makes this a 0, but 3x plus 0 is just 3x. And then I need to get rid of the 3 by doing the opposite of multiplying, which is to divide. I divide both sides by 3, and I get x is equal to 3. And there is my final answer for the bell ringer there. This is a diamond math bell ringer over here, and this one we should know by now that we're multiplying to get the top number and adding to get the bottom number. And I'm not giving the answers out for that one. I'm just putting this here for students that may have been absent. Okay, let's take a look at an example of an equation that actually has rational numbers inside it. Remember, rational numbers are anything that can be expressed as a fraction, a over b, where a and b are both integers and b, the bottom, is not 0. So we're talking about fractions, repeating decimals, terminating decimals. Those are all rational numbers. Working with these fractions here. Now I know how everyone just loves to work with fractions, so we're going to get rid of the fractions. And we're going to do that by working with the LCM. That would be the least common multiple of the denominators. Well, the denominators here are 12 and 4. 12 is the largest number. 4 does go into 12 evenly, so it turns out the least common multiple is the 12. So I'm going to multiply both sides of the equation by 12. Remember, according to the multiplication property of equality, as long as I multiply both sides of the equation by the same thing, the equation is still true. Now, when I do 12 times 5 twelfths, if I put this over 1 and multiply these, I could cross-cancel, and I end up getting just the numerator of 5. And if I do 3/4 times 12, I could do some cross-canceling here. 4 goes into 4 once, 4 goes into 12 3 times. I end up with 3 times 3 is, oops, not 3. 3 times 3 is going to give me 9. All right, so now I end up having 5x is equal to 9x, the 3/4 times 12, minus 4 times 12, because remember, I did say everything. This is being distributed to both this 4 and the 3/4, so 12 times 4 is going to give me a 48. Then I would draw those railroad tracks. Now, normally I like to move the larger coefficient x over to the smaller to the larger, but whenever I have no constant on one side, when I just have a term without a constant there, that's the side I want to move the variable to, because it saves steps later. So if I subtract 9x, I'm moving the 9x over to this side. That's going to give me a negative 4x. 9x minus 9x becomes 0. And then I still have the negative 48 over there. Then I need to divide by -4 to continue the solving process because I still don't have the x alone. But now, when these cancel out, I do end up with x equals negative divided by negative is a positive, so I end up with x equals a positive 12 as my final answer. All without having to work with fractions. If I just convert them all to whole numbers by multiplying by the LCM, then I don't have to worry about fractions. Okay, this example comes straight from our textbook. We have 5, 6y plus 1 equals 1/2 y plus 1/4. And we're going to start by working with finding the LCM to get rid of the fractions. So we have 6, 2, and 4. And first I asked, does 2 divide into 6 evenly? It does. Does 4 divide into 6 evenly? And it doesn't. I get a 1.5, so that's no good. So then we multiply the largest denominator by 2, which gives us 12. Does 12 divide by 2 evenly? Yes, we get 6. Does 12 divide by 4 evenly? Yes, we get 3. So 12 does divide by all 3 evenly. All right, so now we know we're going to be multiplying the entire equation, both sides of it, by 12, the least common multiple. 12 times 5, 6 on the side here. We do some cross canceling. We're going to have 6 goes into 6 once, it goes into 12 twice. That gives you a 10. 12 times 1/2. 2 goes into 2 once, goes into 12 6 times. That's going to give you 6. 12 times the 1/4. We do the cross canceling. 4 goes into 4 once, goes into 12 3 times. We end up with a 3. I did this because over here we're going to be multiplying by those fractions. So I distribute the 12 to all 4 terms on both sides of the equal sign. 12 times 5, 6, y is going to give me a 10y. 12 times 1 is 12. Equal sign is still there. 12 times 1/2 is giving me 6y, and 12 times 1/4 is going to give me 3. Draw the railroad tracks. Here, the 6y is the smaller coefficient on the term with the y. Since we do have variables on both sides, I need to move one of them to the other. I'm going to use the 6y because I like to move the smaller towards the larger. So I'm going to subtract 6y from both sides. I end up with 4y plus 12 is equal to, these cancel, 3. Now it's just a two-step equation. I subtract 12 from both sides. I get 4y is equal to -9. Then I would divide both sides by 4, and my answer ends up being y is equal to -2 and 1/4, which is -9/4 converted to a mixed number answer. Okay, rational numbers also includes decimals. And there is a way to get rid of decimals inside of a problem as well. Now remember, when you multiply by a power 10, you would be moving the decimal to the right, making it move to the right would end up making, well, if I move this to the right twice, it would make this a whole number. And remember, if I multiply everything by the same number, the equation is still true. So in this case, since the largest number of decimal places is 2, if I were to multiply by a 1 with 2 zeros, 100, that would move this decimal place 2 places, this decimal place 2 places, and this decimal place 2 places. I'd end up with 360x is equal to 160x plus 224. Same equations, but now no decimals. Moving the variables to one side, I would subtract 160x from both sides. That's going to give me 200x is equal to 224. Then I would divide by 200, which would give me x is equal to 200 goes into 224 once, with 24 left over. But if we start with decimals, our answer should not end with a fraction. It should end with a decimal. So I have to convert this part here to a decimal. Well, if I divide both the top and bottom by 2, that would give me 12 over 100, which would give me the decimal of 0.12, which means that I have x is equal to 1.12, and that's my final answer. Using a calculator, I could have gone straight from here and done 224 divided by 200, which would have given me the 1.12 right inside the calculator. But without the calculator, we'd still end up with the same answer as long as we worked it out properly. Hopefully this has been helpful. Thank you very much. I'll see you in class.